Azure Functions is a serverless compute service that enables you to run event-triggered code without having to explicitly provision or manage infrastructure. This allows developers to focus on building and deploying applications faster, as the underlying infrastructure is managed by Azure. Azure Functions can be used for a variety of tasks, including processing data, integrating systems, and building simple APIs and microservices. The service is designed to scale automatically and handle thousands of requests per second, making it ideal for applications with varying workloads. Azure Functions offers several benefits, including cost efficiency, scalability, and ease of use. Since you only pay for the compute resources you use, it can be a cost-effective solution for many applications. The automatic scaling feature ensures that your application can handle increased traffic without manual intervention. Additionally, Azure Functions supports multiple programming languages, including C#, JavaScript, Python, and Java, making it accessible to a wide range of developers. The integration with other Azure services also simplifies the development process. Triggers and bindings are fundamental concepts in Azure Functions. A trigger is an event that starts the execution of a function, such as an HTTP request, a message in a queue, or a timer. Bindings provide a way to connect to other services and data sources, such as Azure Blob Storage, Cosmos DB, or Service Bus. They simplify the code by handling the connection and data retrieval, allowing developers to focus on the business logic. Triggers and bindings can be configured using the function.json file or through the Azure portal. To create your first Azure function, you can use the Azure portal, Visual Studio, or Visual Studio Code. In the Azure portal, navigate to the Functions section and click on Create a Function app. Follow the prompts to configure the app, including selecting a runtime stack and region. Once the app is created, you can add a new function by selecting a template, such as an HTTP trigger or a timer trigger. Write your code in the provided editor, and then save and test your function. The process is straightforward and allows for quick deployment. Developing Azure Functions locally can be done using Visual Studio or Visual Studio Code. First, install the Azure Functions core tools, which provide a local runtime environment. Create a new project and select the desired template for your function. Write your code and use the local runtime to test and debug your function. This local development environment mimics the Azure environment, allowing you to ensure your function works correctly before deploying it to the cloud. Once satisfied, you can publish your function directly from your development environment. Deploying Azure Functions can be done through several methods, including the Azure portal, Visual Studio, and Azure DevOps. In the Azure portal, you can deploy your function by selecting the Deploy option and following the prompts. In Visual Studio, you can right-click on your project and select Publish, then choose your Azure subscription and function app. Azure DevOps provides a more automated approach, allowing you to set up continuous integration and continuous deployment (CI/CD) pipelines to deploy your functions automatically whenever changes are made to the codebase. Monitoring and troubleshooting Azure Functions is crucial for maintaining the health and performance of your applications. Azure provides several tools for this purpose, including Application Insights and Azure Monitor. Application Insights offers detailed telemetry data, such as request rates, response times, and failure rates, helping you identify and resolve issues quickly. Azure Monitor provides a centralized dashboard for monitoring the performance and availability of your functions. Additionally, you can set up alerts to notify you of any critical issues, ensuring that you can take immediate action to mitigate problems. Azure Functions automatically scales based on the number of incoming events, making it ideal for applications with variable workloads. The scaling is managed by the Azure Functions runtime, which adjusts the number of instances running your function based on demand. You can also configure scaling settings to control the maximum number of instances and the scaling behavior. For more advanced scenarios, Azure Functions supports durable functions, which allow you to define stateful workflows that can scale across multiple instances. This ensures that your application can handle complex, long-running processes efficiently. Security is a critical aspect of developing and deploying Azure Functions. Implementing best practices ensures that your functions are protected from potential threats. Use managed identities to securely access other Azure services without hard-coding credentials. Implement input validation and output encoding to prevent injection attacks. Use Azure Key Vault to store sensitive information, such as connection strings and API keys. Additionally, configure network security groups and firewalls to restrict access to your functions. Regularly update your functions and dependencies to patch any security vulnerabilities. Azure Functions can be easily integrated with other Azure services, enhancing the functionality of your applications. For example, you can use Azure Functions to process messages from Azure Service Bus, store data in Azure Blob Storage, or interact with Azure Cosmos DB. These integrations are facilitated through triggers and bindings, which simplify the code and reduce the need for boilerplate code. By leveraging these integrations, you can build more robust and scalable applications that take full advantage of the Azure ecosystem. Managing costs is an important consideration when using Azure Functions. Since you are billed based on the number of executions and the execution time, it's essential to optimize your functions to minimize costs. Use the Azure Pricing Calculator to estimate your costs based on expected usage. Implement efficient coding practices, such as minimizing the execution time and reducing the number of external calls. Monitor your usage and set up budget alerts to keep track of your spending. By managing costs effectively, you can ensure that your application remains cost-efficient while meeting performance requirements. Azure Functions offers several advanced features that can enhance your applications. Durable functions allow you to define stateful workflows, enabling complex, long-running processes. Proxies provide a way to define APIs and route requests to different back-end services, simplifying the management of your APIs. The Premium plan offers additional features, such as VNet integration, increased scaling limits, and enhanced performance. Additionally, Azure Functions supports custom handlers, allowing you to use any language or runtime that can handle HTTP requests. These advanced features provide greater flexibility and control over your applications. Azure Functions is used in a variety of real-world scenarios, demonstrating its versatility and power. For example, it can be used to process data from IoT devices, handle real-time event processing, and automate workflows. In e-commerce, Azure Functions can manage inventory updates, process orders, and send notifications. In finance, it can handle transaction processing, fraud detection, and reporting. The serverless nature of Azure Functions makes it ideal for applications that require rapid scaling and minimal infrastructure management. These use cases highlight the potential of Azure Functions to transform and streamline business processes. Following best practices for developing Azure Functions ensures that your applications are reliable, scalable, and maintainable. Use dependency injection to manage dependencies and improve testability. Implement logging and monitoring to track the performance and health of your functions. Use version control to manage changes and collaborate with other developers. Write unit tests to validate the functionality of your code and catch issues early. Additionally, follow coding standards and guidelines to ensure consistency and readability. By adhering to these best practices, you can build high-quality applications that meet business requirements. Azure Functions provides a powerful and flexible platform for building serverless applications. By understanding the key concepts, such as triggers and bindings, and following best practices, you can develop robust and scalable applications. The integration with other Azure services and the advanced features, such as durable functions and proxies, offer additional capabilities to enhance your applications. As you continue to explore Azure Functions, consider experimenting with different use cases and scenarios to fully leverage the potential of this service. The next steps include deepening your knowledge through hands-on practice and exploring advanced topics to further enhance your skills.